What is up, amigos? Today we're talking about tripping boundary layers. So we'll be going through what it is and why we want to do it and then how to do it. So first of all, what is it? So let's say we have a regular plate and the flow comes along here and it develops into a regular boundary layer, and the boundary layer is quite laminar. And as we go along, we know that if the plate is long enough, eventually the boundary layer will transition to turbulence. And if you don't know about this, check out this video here where we go through boundary layers and this kind of thing. But often the boundary layer will transition by itself and not at the point that we want it to transition to turbulence. So what can we do? Well, this is where boundary layer trips come into it. So what we do is on this surface, we put some kind of object, and we'll get into a second what these objects can be, the shapes of them, for example. And then this boundary layer impinges upon this object and then it introduces a lot of turbulence. So we get a lot of vortices coming off here, which then are in the boundary layer. They break down three-dimensionally, and then the boundary layer post obstacle here becomes turbulent. So when we manipulate the boundary layer from laminar to turbulent through this mechanism, that is called tripping the boundary layer. So we're tripping it from laminar to turbulent. And we do that by introducing a lot of turbulence from this object in the boundary layer. So that's all well and good, but why would we want to do this? Why would we want to artificially trip a boundary layer from laminar to turbulent? We know that if we do that, the skin friction here is higher, which means that the skin friction drag will increase. So that's one negative aspect, but why would we want to do this normally? Well, one major benefit is, let's say we have a wing or any curved surface, let's say it's a curved surface like this, and the flow comes over. We know from experience that, and if you don't know, check out this video here on airfoils and how they stall, etc., that the boundary layer here, as it comes along, it will become more and more turbulent, but it will get to a point where there's a lot of adverse pressure gradient, and that results in the boundary layer stalling. It lifts off, so the curve here will stall. And that's because the velocity near the wall is not nearly high enough to withstand this adverse pressure gradient enough to stay attached. But if we were to trip the boundary layer, we can then make it much more turbulent in profile, which means that the velocity near the wall here is much faster, and it can travel further along this curve and withstand this adverse pressure gradient before it finally lifts off. So instead of detaching here, it might detach here, or it may stay attached the entire way, which is the jackpot. So by turbulating the boundary layer, we can make the flow stay attached longer, which means that we can push airfoils, for example, to higher angles of attack and still produce enough lift and not much drag. But another major benefit or another major effect, which can be a benefit or detriment, whichever way you look at it, or what you need to achieve, is that these turbulators, these trips, when they go to a turbulent boundary layer, the heat transfer properties of this boundary layer is different to this boundary layer. So if you wanted to increase heat transfer, you can go to one type, you can trip it if you want, or you can keep it not tripped if you want to reduce heat transfer, that kind of thing, if you have that balance to consider. So there's more than just keeping the flow attached. And if we have the flow attached, it means that the pressure drag will drop, because as we know, if the flow separates, we get quite a big wake here, and then the pressure drag will increase. So if we keep the flow attached, the pressure drag will drop. So those are a couple of the major benefits of tripping the boundary layer. So the final question is, how do we do this? What kind of object do we use? How do we just go about this? So let's say we're looking from the top. So we're looking from this view down here, and we have this plate. There are a few different ideas that we can use. One is we can just use a typical just little rectangular step, which we have here, which spans the entire width or however far you want. And this will work to trip the boundary layer. And the reason why is because it takes advantage of the natural three-dimensional tendency of a flow. So if we have the flow coming along here and then we see a two-dimensional cross-section and it hits this thing and then we get two-dimensional turbulence, it will start off as two-dimensional and then it will start to fan out into three dimensions. And by the time we get downstream, now the entire boundary layer here has become turbulent in its three-dimensional nature. So that is a very beneficial property of boundary layers in this particular circumstance. If on the other hand you wanted to keep the boundary layer laminar, then this three-dimensional nature is detrimental. But here, this is what we like. So you can just use a typical rectangular cross-sectional trip here, and the height that it should be depends on the shape of it, But generally speaking, if you have one about the same height as the boundary layer, that's more than enough to trip it. You can get good boundary layer trips that can be like 1/10 the height of the boundary layer and still trip the boundary layer, so that's pretty good. Another very common boundary layer trip is something called a zigzag strip, so it looks like this. And these are often just like literally like sticky tape kind of things that you just stick on, and then they have a little bit of a height, so they might be like this high or whatever. And what happens is the flow comes along and it hits this one, it creates vortices on each side. So already this three-dimensional strip, which is like this zigzag shape, is producing three-dimensional turbulence. So you don't have to wait until we're going downstream for this two-dimensional turbulence to break down three-dimensionally. It's already three-dimensional. So that really takes some of that time out of the equation, and also you can actually use a smaller height of this trip and still trip the boundary layer quite well. So that is boundary layer trips and why we use them generally speaking, and why we'd want to use them to do that, and how to do it, and these different geometries. So if you like this video, make sure to like it, and if you want to see more like this video, check out this playlist here, and I'll see you next video. Peace out, amigos.